Hey everyone! So we're diving into something pretty wild today. A new paper from Meta's superintelligence labs that's been making waves. It outlines a way for an AI to teach itself, to get smarter and smarter, potentially forever, all without needing any new data from us. Yeah, you heard that right. Let's get into it.
It's really the elephant in the room for the entire AI industry. This whole AI revolution has been built on one simple idea: feed the machine more data and it gets smarter. But what happens when we reach the end of the line? When we've scraped every corner of the internet and there's just nothing new for it to learn from?
And that brings us to what some researchers are calling AI's Great Data Wall. It's this massive, looming obstacle that could seriously slow down the incredible pace of progress we've all gotten used to. Think about it. Right now, models like Llama or GPT learn through something called pre-training. It's like they're forced to read a library the size of the entire internet. They just soak up all this information about language, logic, and, well, pretty much everything we've ever written down. But here's the kicker. This whole approach has an expiration date. We are literally running out of high-quality human text to feed these things. Some forecasts say we could completely tap out our public data reserves in just the next couple of years. So the question is, if there's no new information to learn from, how do these models possibly keep improving? Wow, this is where things get really interesting. This paper proposes a totally different way of thinking. It's a real paradigm shift, where the AI starts learning from the inside out, completely bypassing the data problem. Let's take a look at how this new paradigm actually works. So let's break this down. The old way is static. You hand the AI a giant fixed textbook, the internet, and it just studies it. But this new method, which they call language self-play or LSP, is totally dynamic. The AI essentially writes its own curriculum. It creates its own increasingly difficult textbooks to learn from. It's a completely self-contained loop that needs zero outside data. The magic behind this is a concept called self-play, and if you followed AI, you've definitely seen this before. Just think about a chess program like AlphaGo. It didn't become the best in the world by studying games played by humans. No, it got there by playing millions and millions of games against itself, discovering strategies that no human had ever even thought of. This paper takes that exact same idea and applies it to language. So, how does this game actually work? The researchers basically set up this internal showdown, splitting a single AI model into two different roles. You've got the challenger and the solver. The solver's job is pretty simple. Be as helpful and as accurate as you can be. It's trying to rack up the highest score possible. Then you have the challenger, and its job is to be a total pain. It's the adversary, constantly cooking up harder and more complex problems to try and stump the solver. It's this constant tug of war. But here's the key. Both sides are part of the same AI, which forces the whole system to get smarter and more capable together.
And this is where the design is just brilliant. As the paper says, it all happens inside just one language model. You don't need a second separate AI to act as the bad guy, which would be super complicated to manage. Instead, one model is playing both roles, creating this perfectly autonomous training loop. And you can literally see how this escalates. At first, the challenger is asking pretty standard stuff, reasonable questions. But as the solver gets better, the challenger has to get more and more creative. A few hundred rounds later, it's asking for a submarine built from a scuba tank. And then it gets even crazier, asking the model to invent a whole new programming language on the spot. It's constantly pushing the very edge of what the model can do.
Okay, but there's a potential problem here, right? If you let this game go on without any rules, it can just fall apart. The challenger could start spitting out impossible nonsense, or the solver could figure out some cheap trick to get a high score without actually being useful. That's something called reward hacking. So the solution is super clever. The AI also plays the role of its own referee. It creates a quality score for the entire back and forth. This means the challenger gets rewarded for being tough, sure, but it also gets rewarded for asking questions that are clear and useful. This keeps the whole game grounded in reality and stops it from just spiraling into chaos.
All right, that all sounds amazing on paper, but the million-dollar question is, does any of this actually work in the real world? Well, the researchers ran the experiments to find out. And the results are, well, they're pretty jaw-dropping. Look at this. On the far left, that's your standard model, trained the old-fashioned way with human data. The next two bars, that's our new self-play method, trained with absolutely zero new data. And their performance is practically identical. This is huge. It's the proof that data-free improvement isn't just a theory, it's possible.
But then they took it even one step further. They thought, okay, what if we take an AI that's already been trained on data and then let it play against itself? And look what happens. Self-play acts like an afterburner, boosting the model's performance even higher. So it's not just an alternative to data-driven training, it can be the next powerful step up.
And this is the really cool part. The biggest improvements were in these really complex, open-ended conversations, which makes total sense, right? The model got better at exactly the kind of tough, creative problems that its own internal challenger was forcing it to practice. The whole process works just like it was designed to.
Okay, so let's zoom out. What does all of this actually mean for the future of AI? Why is this so much more than just a cool engineering trick? I mean, this really opens up some incredible doors. We're talking about a path to AI that can just keep getting better on its own forever. It means we're less dependent on the finite amount of data we've created. It could even mean that AI can start to explore ideas and generate knowledge that's beyond what we currently know. It's a huge step toward more autonomous, more capable AI systems. And that just leaves us with this one kind of mind-bending question to chew on. If a machine can truly get caught in a loop of perpetual self-improvement, constantly finding its own weaknesses and then creating its own training to fix them, where does that road end? Are there even any limits? Something to think about. Thanks for tuning in.